In the previous video, I introduced the probability theory. In this video, I introduced the set theory that is closely related to the probability theory. I will begin with some definitions to introduce the set theory. The first definition is a subset. If each element of set C1 is also an element of set C2, then the set C1 is called a subset of the set C2. Using a Venn diagram, we can express a subset in this way. So if this one is a C2 and C1 is a subset of C2, then C1 is going to be inside the C2. If C1 is a subset of C2 and C2 is a subset of C1, then these two sets must have the same elements and equal. So C1 should be same as C2. If a set C has no elements inside, C is called the null set with this notation. Or we can write the empty parenthesis. The set of all elements that belong to at least one of the sets C1 and C2 is called the union of C1 and C2, which is illustrated as the combined yellow area in the first Venn diagram. The notation for the union is called a cup because it looks like a mug. The set of all elements that belong to each of the sets C1 and C2 is called the intersection of C1 and C2, which is illustrated as the common yellow area in the second Venn diagram. The notation for the intersection is called a cap because it looks like a baseball cap. The set that consists of all elements of the sample space that are not elements of C is called the complement of C. And we use the superscript C to denote the complement. The third Venn diagram illustrates that the outside area corresponds to the complement of C. A function is an association that relates one quantity with another quantity. A point function, f of x, takes a point as an input. For example, f of x is equal to x plus 1, where x is a real number. So f of 3 becomes 3 plus 1, which is equal to 4. So this is the input, this is the output. A set function, q of c, takes a set of points as an input. Let's consider the example of the set function. When c is a set of real numbers, q of c is the number of positive integers. If c is a real number that is greater than 0 and less than or equal to 5, then q of c is the number of positive integers. So 1, 2, 3, 4, 5, so it becomes just 5. Another example of QC is the summation of f over the set C, where f of x is given by this. Because f of x can be evaluated only for positive integers, when C is given by this, x in C can be either 1, 2, or 3. So this q of c will be 1/2 when x is equal to 1 plus 1/2 when x is equal to 2 plus 1/2 when x is equal to 3, and it becomes 7/8. Let's consider another example. Now q of c is an integral function given by this. If c is a set of non-negative real numbers, q of c becomes the integral of e to the minus 2x from 0 to infinity. And then we can just do this integral and it becomes 1/2. If c1 is an interval between 0 and 2 and c2 is an interval between 1 and 3, then intersection of c1 and c2 is given by something like this. So closed, closed, this one is a c1, closed, closed, this is the c2, and then this is the common interval. So this one corresponds to c1 intersection c2. So q of c1 cap c2 is the integral of e to the minus 2x from 1 to 2, and then we can just do this integral, which is 1/2 times e to the minus 2 minus e to the minus 4. In the next video, I will introduce the probability set function based on what we learned in the probability and set theory.